As part of the automatic collision checking, FeatureCam 2015 has an additional function called Machine Maximum Stock. This option reduces the number of retractions when used with automatic collision checking, keeping the tool on the part to improve surface finish. This option can be applied to parallel, radial, Z-level finish, Z-level interleaved, spiral 3D, rotary, steep and shallow, isoline and flowline surface milling features. In this example, we have a pattern for a racing car cowling. What we want to do is we want to run a parallel toolpath across this pattern mold. We've already got 3 toolpaths already created. The first one doesn't have the checking switched on, the second one does, and the third one uses this new option. Let's just look at the first toolpath first of all. I'm going to go to my options simulation, just verify that I've got pause and gouge switched on, and I've also got my show holder switched on as well. If I calculate this first toolpath, let's do it as a centerline simulation just to display the toolpath itself. And you can see we get a nice continuous complete toolpath across the entire component. So we can see the tool going down into these areas continuously, and we don't see any apparent problems. However, if I play this as a 3D simulation, and in this case I've set my stock just to be the part itself, and then play this, what you'll see is we get collisions as the tool collides into the material. If I was to switch these collision checking off, just play that again, you can see the magenta areas where the tool holder has collided with the part. We're going to get several areas where this is happening. So obvious areas are here and here, but there are also some less obvious areas if you wish to continue the simulation down here and at the front of the part as well. So to rectify that, we've included the automatic collision checking. So this second toolpath, if I go and have a look at the settings on the strategy page, you can see this one has holder collision clipping switched on. And in the finishing tab, in the milling, you can see we've selected a holder clearance, in this case of 1mm. The shank clearance we left as 0. If I go ahead and play the centerline simulation again on this one, you'll see areas or segments of the toolpath have been clipped or removed. This is to avoid the collision of the holder into the part geometry. However, by doing this, what you can see is the tool, because it can't get any closer to the model itself, we've got these direct moves that are going to leave witness marks on the part and leave quite an unsightly surface finish. If I go ahead and play a 3D simulation just to verify, in this case, switching on the gouge checking for the simulation, we will at least verify that there are no collisions on the part where we saw before. But we're still left with this witness mark issue. So to fix that, we use the new option with the collision avoidance, which is the Machine Maximum Stock. So what this does is it's designed to keep the tool continuously flowing through the toolpath without any lifts or retracts, so it keeps the toolpath segments continuous. If I was to play this as a centerline simulation, the toolpath looks very similar to the original, which didn't have the collision checking. However, if you rotate the part round and look at the different toolpath segments, for example, at the back here, you can see the tool gets to the collision situation and then pulls away from the part and then rejoins to prevent the collision. We can see obvious areas, for example, at the front of the component, here, and inside this recess, we can see the toolpath again, like so. I'm rotating just around to this region as the less obvious area, where the tool has pulled away from that edge and given us our collision-free region here as well. This avoids those witness marks as the tool was dragging along those surface areas and keeps the tool as continuous as possible. We can re-verify this with our 3D simulation just to make sure there are no collisions with the part, but that we have a continuous tool path to give us a nice surface finish.